Now I'll discuss about the first year. I'll discuss about the what is the chemical bonding and why we need for that. Okay, so for the chemical bonding, when the atoms we are discussing about, atoms are considered as they are considered as a tiny structure of any substance. Okay, so in which is considered as a really stable. Okay, so in that cases of that which is considered as a really stable, so in that case the every element present in the nature they needs a stability. Okay, and for that consider as for stability they are allowed to get fulfill their outermost orbit. Okay, that's considered as, and in which they are allowed to for the fulfill of the outermost orbit with electron they are allowed to be get follow the octet rule. Okay, they according to the octet rules what is said, as we know atomic structure in which a central part is considered as a nucleus. Okay, in which the protons and the neutrons are present. Okay, and the electron which will around the nucleus in the shells. Okay, so in that case we are considered as a electrons which is revolving around the nucleus in the cells. Okay, every cells have the number of specific number of electron can be stay in a one cell. Okay, so in that case we are considered as a octet means we are considered as a 8 number of electron should be present in the outermost cell of the elemental atomic structure. Okay, if it's have already 8 electron in their outermost cell. Okay, so this is considered as a stable element. Okay, and if there is no 8 electron, okay, if there is a less number of electron is present in the outermost cell which create the instability. Okay, so in that to get the stability the electrons the atoms get allowed to take a part in chemical bonding. Okay, so for that chemical bonding they allow to make interact with the other element or the same type of the element to fulfill their outermost octet. Okay, means the element in the chemical bonding the element get it attract with each other. Okay, to fulfill their electron fulfill their orbit we can say with electron. Okay, so in that case they needs to make a interaction with the same number of element or the other type of element. Okay, so that's why this interaction between the elements are considered as a chemical bonding. Okay, so for this interaction they have chemical bondings have the different type of them. Okay, in which most commonly chemical bonding primarily divided into two parts. One is considered as a strong bonding and one will consider as a weak one. Okay, in the strong bonding we are most commonly will discuss about the four type of bonding. Okay, in its first part we'll consider as a ionic bonding. Second we are considered as a covalent bonding. Third we are considered as a coordinate bonding. And the fourth one we are considered as a metallic bonding. Okay, in that weak bonding it's divided into commonly two parts. One is considered as a hydrogen bonding
Yeah.
and one we'll consider as a van der Waals interaction.
Okay.
So I'll give the completely brief idea about this, okay, and the complete knowledge about that covalent bonding what you want, okay. So in that case, the primarily as we discuss about the chemical bonding is just to make an interaction between the same or the different type of elements, okay. If we are considered as a ionic
Yes.
bonding
Okay.
part, okay, in that ionic bonding, primarily ionic as a word say is related to the bonding between the ions.
Yeah. Okay.
So in that case, we are allowed the bonding when two different ions get react with each other and make an interaction between each other, okay. One we are considered as a positive ion, one will get considered as a negative ion, okay. And the positive ion also we can say the cations, okay, and the negative ions we are considered as anions, okay. When both get interact with
Yeah.
each
Okay.
other and form a one complex, or they can say the compound, that compound is considered as a ionic compound, and
Hello.
this ionic compound, hello.
Yeah. I'm here.
So it will consider as this ionic compound when it is formed, the interaction between the two elements that is considered as a ionic interaction, okay, in which always be one element which take a part that should be metal and the another one should be non-metal in nature, okay.
Yeah. Yeah.
So which is metal that work as a cation and which is non-metal it would be work as a anion, okay. Because how will get the cation charge and the anion charge? The cation means it will allow to will who will give the electron, okay, from their
Yes. Okay.
outermost cell,
Yeah.
in like who will and ions were considered as a which is take the electron in their outermost cell, okay. So in that case, for example,
Yeah.
I have a one metal and non-metal complex, okay. Suppose like for I'll take one metal that is sodium, okay,
Yes.
and the one non-metal I'll consider that is chlorine,
Yeah. Okay.
okay. Sodium is represented by Na, whose atomic number is 11, atomic mass is 23, and chlorine I'll represent it by the Cl, whose will consider as a atomic number is 17 and atomic mass will consider as a 5, okay. So in that
Yeah.
case,
Okay.
once I'll make the atomic structure of both, it's represented like this: proton and neutron present in center, first cell have 2 electron, second cell have occupied with the 8 electron, and outermost cell have 1 electron. So its configuration is 281 because total electron is have 11, okay. So that is the electronic configuration of sodium. Same as if we'll make the atomic structure of chlorine, it will represented proton and neutron in center, 2 electron present in that one, 8 electrons present in that one, and the 7 electron is present in the outermost cell. Okay, so its electronic configuration is 287. Right? So now its outermost cell is also incomplete with the number of electron, and this one is also get incomplete. Okay, so in that reason, if you see, its need according to the follow of octet rule, this should be outermost cell should be occupied with a complete filled with the 8 number of electron. So for this sodium, its need 7 electron, right? And the chlorine needs 1 electron. Okay, so the sodium have the two options here. One, it can give this 1 electron to another one. Okay, and this cell is get moved out, and this one, the inner cell, become the outermost one, which is already filled by the 8 number of electron. Okay, another one, it can take the 7 electron from the other side and get full there this one outermost orbit. Okay, but the 7 electron to take from the any one element, it will take more energy. Okay, so due to that, I'll choose that option because it is metallic in nature. So due to that, that will allow to give this 1 electron to chlorine. Okay, then the structure comes after give 1 electron, the sodium metal get 1 charge. Okay, and structures comes like this. Okay, this outermost cell is get disappear because there is no electron. Now the electronic configuration of sodium is 2 8. Outermost cell have 8 electron. Okay, and the chlorine structures comes 2 8, and the 8 number of electrons comes in outermost cell. One is given by the sodium, so its configuration is also 2 8 8. That is also have 8 electron in the outermost cell. Okay, so due to that, who will give electron that will get positive charge? How will get the positive charge? Because generally will consider as in atom general structure. Okay, number of protons and the number of electrons are equal. Okay, and the proton charge is positive and electron charge is negative, so both are allowed to neutralize each other. Okay, that's why in atomic structure they not have any charge. Okay, but once it will allow to give electron, the sodium, so in that state, in this state, sodium have proton value is 11, electron value is 11. So which is negative, this one is positive. So 11 positive, 11 negative, they will get cancel out each other, so there is no charge. Okay, same things happen here. It is also have 17 proton and 17 electron, so due to that they will also get cancel out each other, so there is no charge also. Okay, but now after giving take of 1 electron, there is proton value is same 11. Okay, and electron value will come 10 because 1 electron is given to this one. Okay, so due to that, this 10 electron have a capability to cancel out 10 proton. 1 proton is left, means 1 positive charge comes. Okay, then here also we will consider as a, because the proton value is 17 only, but 1 electron is comes by from the sodium, so that's why it's get a 1 negative charge, so that's why the value come 1 negative. Due to that, a charge will come on sodium plus 1 and the chlorine -1. Now the sodium is not considered as a sodium element, now it's considered as a sodium ion. Okay, and this one is become from chlorine to chloride ion. Okay, so
Yeah.
this interaction due to the formation of the give and take of electron, okay, occur between the one metal and non-metal. This interaction allowed to form a bonding between metal and non-metal that is considered as the ionic bonding. Okay,
Yeah.
so now the reaction from sodium ion plus chlorine ion get react with each other and convert into NaCl complex, okay, which is also considered as a ionic complex or ionic compound. Okay, you get it about the ionic bonding?
Yeah, I've understood.
Or any doubts you have till now?
No.
Okay, so most commonly the point we are considered because this is the interaction between the two different ions, so that's why its bonding is from a very strong interaction between the metal and the non-metal.
Yeah.
Okay, second one, always we are considered as a there is one should be always in metal and other should be non-metal, and metal always we work as electropositive and the non-metal always will work as a electronegative. Okay, so this interaction is just made up of by the give and take of electron. Okay, one will
Yeah,
give
okay.
and one will allow to take, that is considered as a ionic bonding. Okay,
Yeah.
same as we'll discuss about the next one, we'll consider as a covalent. Okay, in the covalent bonding, that is also will consider as a strong bonding part. Okay, but this interaction is not formed by the give and take of electron. Okay, it allowed to follow the principle for being the complete interaction between the part any metals any ions, okay, or you can say any elements. So that is the interaction is occur by the sharing of electron. Okay,
Yeah.
in it first point they follow the principle sharing of electron. Second one, always there is metals are not allowed to take a part in covalent bonding. Both the elements which are allowed to take a part in bonding that should be non-metallic in nature. Okay, means here in covalent bonding one non-metal gets share its electron with the another non-metal. Okay, and allowed to make an interaction between each other which is called the covalent bond. Okay, that point we'll consider as a there is no formation of any kind of charge occur. And next one we'll consider as is always be follow up how many number of electron is required for the outermost cell. This number of electron allowed to share with the another metal and get joined interacted at that particular position. Okay, for example, one side you have the hydrogen, okay, and another side you have like oxygen. Okay, so in that case if you consider as a hydrogen or structure, it's have a one atomic number and one atomic mass. Okay, this is hydrogen, and oxygen have 8 atomic number and 16 atomic mass. Okay, if I made the structure of hydrogen is look like this, it's have one proton and one electron in their outermost cell. For the oxygen, it's have proton and neutron in center part, 1 electron and 2 electron in first one, 6 electron in the outermost. Okay, its configuration is 2 8, its configuration is 1. Okay,
Yeah, okay.
so in that case, for hydrogen needs 1 electron. Okay, because primary cell have a capability to fulfill by the 2 electron, but hydrogen have only 1, so it needs 1 here. Okay, second one, if you consider as oxygen, because the outermost cell is have capacity to carry 8 electron, but the oxygen, because total number of 8 electron it have, so 2 plus 6, so there is capability to add more 2 electron. Okay, so in that case what will happen, they'll not allow to give and take of electron. Okay, they allow to share the electron for both of them. So now, because hydrogen have 1 and oxygen needs 2, so in that case 2 element of oxygen, like this, if you make a structure in center, okay, of oxygen.
Yeah, okay.
So here I'll make 6 electron and 1 is left here, and I will take 1 hydrogen in this part and 1 hydrogen more I will take. Okay,
Yeah, okay.
so it's also 1 space is left, it's also 1 space is left. Now you have 1 hydrogen, 1 oxygen and 1 more hydrogen. So here these parts are allowed to take a interaction in which these get completely get interacted to the place of another metal, like this position. Okay, so the structure comes after interaction. Hydrogen get attached with that position, yeah, and attach its electron like this. Okay, same as in that position the hydrogen get attract and they'll allow to get position of this side. Okay, so now if you see, with the sharing of hydrogen's 1 electron, it's get 1 more electron which is present on the outermost cell of the oxygen. Okay, and because it's need only 1 electron, so this the first orbit of the hydrogen is get fulfilled by the 2 electron. Okay, for both of side, and oxygen, if you see, that will also get the 8 number of electron in the outermost cell by sharing. Okay,
Yeah,
so
okay.
this type of the sharing whenever occur between the non-metal elements, okay, that is allowed to call as the covalent interaction.
Yes.
So in that case, we'll consider as this hydrogen makes bonding with the oxygen and the another hydrogen also make a bonding with the hydrogen. Okay, so means 2 hydrogen get joined together with the oxygen and allow to formation of 1 covalent compound, that one is considered as a water. Okay, means 1O plus 2HN that allow to form 1H2. Okay, because this one is also non-metal and this one is also non-metal, so due to that they allow to sharing of electron of each other by attaching on the surface of another element. Okay, so due to the sharing they will allow to get formation of a bond which makes an interaction between the 2 different or the same type of element. Okay, same as if you consider as a this one interaction, covalent is also get divided on the basis of interaction between the same or different type of element, they are get divided into covalent bonding. We'll consider as a two part. Okay. One we are consider as a polar covalent bonding. One we are consider as a non-polar covalent bonding. Okay.
Yeah, okay.
In the polar covalent bonding means where the non-metal which is allowed to take a part in bonding are different from each other. Okay.
Yes.
For example, like here you will consider water, and in water you have the oxygen and hydrogen, and this interaction between the oxygen and hydrogen, because this one is different element, this one is different element, so this interaction is considered as a polar covalent bonding. Okay. Same as if we'll consider as a non-polar, means where the non-metal elements are same. Okay, means the interaction occur between the same non-polar element. For example, like you have inside you have nitrogen. Okay, another side also the second element also you take the nitrogen. Okay, nitrogen is represented by N, and its atomic number is 7 and atomic mass is 14. Another side you also have same one. Okay, if you make the structure, one is okay, it's need 3 electron here. Okay, and for the same of this side it's also need 3 electron to fulfill their outermost. Its configuration is 2,5, so its configuration is also 2,5. Okay, so in that case they are make a interaction in their outermost cell surface. Okay, get completely get attached the surface like and in that case they are allowed to share all these 3 electron for this part and this part. Okay, and this. Okay, now this one share with this part, so this is allowed to make a bonding, a triple bonding, because one pair allowed to show by the single bond. Okay, here if it is considered as a 3 bonds, right, 3 pairing, so
Yeah.
that's why it will consider as a triple bonding occur between the 2 nitrogen atoms. Okay,
Yeah, okay.
so that's why when you have a covalent bonding between the same type of element, okay, both side you have a same type of element, so this type of bonding is considered as a non-polar covalent bond. Okay, polar means
Yeah.
this interaction is occur between the two different types, like H or oxygen will consider as a, either you will consider as a oxygen, nitrogen and hydrogen, in between the interaction will occur. Okay, so there are a number of complex allowed to form the interaction between the two different or the same type of elements. If you have the same, so that is considered as a non-polar. If you have a different, so that will consider as a polar. Okay, in this case we have considered as a polarity is allowed to show charge. Okay, and the non-polarity means there is no charge. Means in this type of polar covalent bonding, it's have some type amount of ionic characters. Okay,
Yeah.
means not so strong, but we can say some amount of ionic character is present in the polar covalent bond. Okay, but in that case, that is considered a pure covalent bond. There is no ionic property is present. Okay, so if we'll get compare between the ionic and covalent bond, okay, because they are the most common and most favorable bond for the metals and non-metal part. Okay, in that case, primarily ionic bond will occur between metal plus non-metal. Okay,
Yeah. Okay.
covalent occur non-metal plus non-metal. Okay, second point we'll consider it allowed to give in check of electron. Okay, between metal and non-metal. Okay, then
Yes.
it will consider as a it allow to sharing of electron between non-metal elements. Okay, they are, we can say, non-metal elements either be same or different. Okay, means the non-metal can be same or the different, but here the element always be different from each other. Okay, then they are allowed to form ions like cations and ions. Okay, but there is no ion formation occur. Okay, so due to that this have the ionic bonding, so the ion allowed to formation, this is considered as a, this is strongest bonding. Okay, in the chemical bonding picture, and it is also strong but as compared to ionic it's weaker. Okay, so that's the most commonly journal feature will occur. And also if you are divided within on the basis of the melting point, boiling point, and the density of the compound is always be higher for the ionic compound. Okay, and in this case covalent bonding comparatively lower. Okay, most commonly it is have the high value of melting and boiling point, but if you compare with the ionic compound that value will consider as a little bit lower. Okay, the number of examples you can put here, like for example NaCl salts, okay, MgCl2, okay, ZNO, one metal, one should be non-metal. Okay, So these allyl compound always be allowed to formed by the interaction of the ionic bonding occur between the metal and non-metal. And here for the example you consider as hello. Hello. So in that case, if we'll consider as for that covalent bonding, there are multiple of other example, like for example water, okay, and you can say the methane gas, and consider as like hydrogen molecule, nitrogen molecule, and the O2. These are all examples of the covalent. Okay, if you have a occur between the different elements of non-metal part, that will consider as the formation of the polar covalent bond. Okay, and if you have the same like this, so they allow to formation of the non-polar covalent bond. Okay, till now you understand? Any doubts you have? You get it, this one?
Yeah, I understand.
Okay, like for example I'll show you in the pictures. See here you can see for the ionic bonding part, here Na will give one electron to the chlorine, so Na get the positive charge after giving and the chlorine get the negative charge. So due to that, once you'll get the positive and negative charge, they get make a interact with each other and they make a allow to formation of ionic bonding. In the covalent bonding, they allow to get shear like this. Okay, so in that case, the normal covalent bond consider the atom provide one of the electron of in bond and represent the short straight line like this. Okay, if like I'll make a interaction like one bond, okay, so means one electron from this side, one electron from this side. Okay, suppose I'll show with a double bonding like, okay, means there is two electron from this side and two electron from this side allowed to share. Total number of sharing of electron is 4. Okay, and if I'll make bonding like this 3, triple bonding, so means here the interaction sharing of electron is number of electron is 6 overall. Okay, so means there is total number of electron value is 6, which will take a part in covalent bonding. Okay. Now if we'll consider as like for example, if you consider one more example for ammonium ion. Okay, so in that case dative amount will allow to share of 2 electrons which provide the electron from both of one. Okay, suppose in ammonium we'll consider as a dative covalent bond where is the pair of electron is shared between 2 elements and one of is provide both electron to bond. Okay, that will also consider as in term of you can say coordinate bonding term. Okay, so in that case if we'll consider as suppose in the coordinate part the third type of bonding. Okay, in coordinate bonding we are considered as that is the relative to the covalent part only, but in covalent I tell you both element allowed to share their electron. Okay, but in coordinate bonding only one element allowed to share their electron. Okay, means from both of side electron is not allowed to share by the any element. Okay, only one element will take a part in the reaction to formation of the bonding between each other, and only one element allowed to share its electron to the another one element. Okay, so this type of interaction will occur in that kinds of, which is called that dative, also you can say the coordinate. Like for example, if you consider the sodium structure, here the sodium structure have this X is represented as sodium electron. Okay, here you can say outermost cell have 5 electron, 2, 3, 4 and the 5. Okay, and each hydrogen have one electron. This one share, this one share, this one share. So these three interaction is considered as a normal covalent bonding. Okay, but here where already the pair of electron is present with the nitrogen, so in that case this completely pair is shared to one hydrogen with its positive charge. Why it's get positive? Because it's already have one electron in the outermost cell, and if 2 electrons comes, and that's it, so there's a one charge become extra, so that's why it's get the positive. Now, and this arrow is occur because here both allowed to share, and here only nitrogen allowed to share its electron to hydrogen. So this type of bonding is shown by the arrow. The arrow is moved to that direction who will give and who will take that pair of electron, okay, to which it will allow to share. Okay. So in that case, consider as this bonding is considered as a coordinate bonding, or also you can say another terminology, dative covalent bonding. Okay, you get it about it? Hello?
Yeah, no, I understand. I'm just trying to
Or
understand.
do you, any doubt with that about the
No, I have no doubts.
about the covalent bonding, or any questions you have till now?
No, I have no questions.
Okay, so in that covalent bonding we are considered as a, because they allow to make a interaction between the electron after completely stable form, and they will allow to fulfill their octavate by the complete sharing of the electron the between two different elements, it is non-metal in nature. So due to that they are regarded as a share of electron pair at the fixed position, so the electronic state it's becoming constant in motion, means the position of electron is not get changed. Okay, the position is get fixed and the element get attached strongly with the another one. Okay, so this type of interaction is considered as a covalent charge, and one side it's allowed to make a completely charged cloud because the electron get gathered at one position together. Okay, so this kind of position are considered as a charged cloud on the non-metallic region.
Yeah,
Okay, so that will consider as a covalent part. Okay, completely in covalent we are considered two type of bonding. One is considered as a on the basis of same type of element or different type of element get make a bonding of the covalent between each other. So the if you have a difference, so that will consider as a polar, and if you have the same type of the element, that will consider as a non-polar. Okay, and if both allow to share their electrons, so they are considered as a covalent bond, and if only one allowed to share their both of electron to the bond, so that will allow to consider as a dative covalent, or another term you can consider as a coordinate. Okay, this type of bonding is always shown by the arrow. Okay, not like this, like ionic or covalent will show. Okay, for any bonding will consider as a, that will shown by the simple dash, but the coordinate bonding is shown by the arrow. Okay, we show the direction from which the electron allowed to share to the another. Okay. Any doubt till now? Any confusion you have?
No, I have no doubts.
Okay. Next one we'll consider in strong bonding. The last part we'll consider as a metallic bonding. Okay. In the metallic bonding, we are considered as it is make a interaction between the cations, like as it will consider in, if you consider for the ionic, as I mentioned, in ionic bonding we make a interaction in that consider, sorry, one second. In that case, if we'll consider as for the ionic bonding, we are making an interaction between the metal and non-metal, right?
Yeah,
Okay, so for that case, if we are consider for the covalent region, okay, for covalent we are consider as the interaction occur between the non-metal and the non-metal. Okay.
Yeah, okay.
And if we'll consider as a metallic interaction, in metallic interaction, this interaction occur between the cations. Cations means metal ions. Okay, means all interaction, if you visualize on the basis of the metals and non-metal nature. Okay, there is metal and plus non-metal, there is both are non-metal, there is only metal ions. Okay, so that's why this bonding have their different nature on the basis of the elements also. Okay, in the metallic region, when we are considered as in the metallic region, when you have, because both metal when they get interact with each other, they have a like sea of electron, because in metallic structure the electrons are free to move in any direction. Okay, there is no fixed direction is present, so that's why this type of movement is considered as there any direction they like to move. This kind of the position occur in the metal, that is called as a sea of electron. Also you can say the cloud of electron. Okay, then when this electron, if you are attached with the any charge unit, okay, suppose one side you are attaching the positive terminal, one side you are attaching with the negative terminal. With the attachment of two terminal, the sea of electron, which is unidirectional, it's become directional because electron have negative charge, right? So due to that, all electron which is have a negative charge, they'll allowed to get cloud at the position of the positive terminal. Okay, because opposite charge get attract with each other, so every electron direction comes this side. Okay, same thing happen here. Like magnesium have two electron in the outermost cell, you make a charge interaction with the opposite part. Okay, so both two electron make a electron cloud between two metal ion. Okay, and this kind of the electron cloud occur between the two charged cations, that kind of interaction is considered as a metallic bonding. Okay, because this is also have two electron in the outermost cell, this is also have two electron in the outermost cell, you give the opposite charge to them, they will get centralized in the between two metal ion. And this kind of the centralization when will occur between the metal ion, due to this interaction the nucleus of both of metal become more stable. Okay, because the ion get allowed to fulfill 4 electron allowed to share with each other, and they will allow to become the most stable structure of metal ion. Okay, so this type of interaction occur between the two cations that are considered as a metallic bonding. Okay, so do you have any doubt with this part?
No.
Any questions you have about that ionic, covalent or coordinate and metallic bonding part? Hello? Okay.
Okay.
So, do you have any kind of doubt with the covalent ionic bonding or covalent? We'll consider as, for example, if you have any doubt with that coordinate, and any kind of, for like, we'll consider any metal ion like ZNO, AgCl. Okay, so this kind of the interaction occurs formation of the complex that is considered as a ionic bonding. For the covalent bonding, you can consider as any non-metal ion get complex with each other like water, and you can say CH4 like H2 have given Na2 N2, and you'll consider as a O2. Okay, and for the metallic bonding, if you're consider as, they'll consider as a 2 G plus 2 ion get interact with each other. Okay, or you'll consider as a 2 Au plus 2 get ion get interact with each other. Okay, so this kind of interaction will occur between the metallic. And if you consider the coordinate bonding, so in that case the interaction occurs, suppose for like ammonium ion, you can say NBF3 NH3 complex, this is complete one complex. Okay, and this arrow, it shows the presentation of coordinate bonding. Okay, these are the
Yeah.
general examples occur between this all this four bonding. Okay, so any kind of doubts